after we have exported it from GPA. So now, just profiling of applications is not good enough. We will also have to see how can we go about optimizing it. So even for that, we have a tool. It is called Intel Integrated Performance Primitive, or Intel IPP for short. What is this Intel IPP all about? Intel IPP is, you can essentially say, this is just a library it will provide you with building blocks for different operations or activities like image processing, signal processing, multimedia, speech recognition, computer vision, video playback, and so on and so forth. So this is essentially a library, so you will really have a .a file that you will have to include in your app. But the point to note here is, to use Intel IPP, your application has to be an NDK application. You have to really be coding or using NDK or the C, C++ based libraries in your application to be able to use these optimized functions with your code. Let's go back to Eclipse and see how do we go about making an app an NDK app. So this is something that Nalina has covered in her webinar yesterday, but I will just run you through this again. So I have two sample applications here. You can see that there is a Hello IPP simple. This is the one that is actually making use of different function calls in the IPP library. But I have created Hello World example. This is just a Hello World application, which is right now not an NDK application. I will just show you how to make this or how to turn this application into an NDK application. So you just have to right click on the project in Eclipse and then go to Android Tools and click on Add Native Support. So this is the simple step required to make an application an NDK application. So this is an operation that has already been done for the first project that you see there, which is the Hello IPP simple app. So if I go to Android Tools here, you no longer see the activate in native support here. That is because it has already been done onto this app. So now how do we go about using the IPP functionality within our code? So once you actually create or turn an application into an NDK app, the first thing that you will see is inclusion of a folder by name GNI. So this is the interface folder for you, or this is the one that actually exports the C and the C++ interface API that can in turn be used by your Java code. So in the Hello World example, we really don't have the interface because we have not defined any, but let's go to the IPP example. There you can see that there is a hello IPP.c. So this is the C interface that can be directly used from your Java code. So there is also a Java part to it. So if you go to the source, there is hello IPP, and this is in turn making use of the C API that has been exposed there. So there are certain, so if you can see here, there is a load library call that is made, which will load the library and you will be able to use interface from your Java code. So what additional things have to be taken care to use IPP or the optimized library for the different operations that I explained earlier is you will have to add some of these definitions into your android.mk file. Specifically, if you note, ones that are really required for usage of IPP is the static library that will be used, which is the IPP Android preview, and the source file that is mentioned here. So this is the actual static library with all the function definitions for IPP within it. So you will have to link with this library to be able to use the optimized library functions provided by IPP. So you will have to mention these in your android.make. In application.make, here you can see that we are trying to build this only for the x86 platform, but you also have the option of building it for all. But then IPP optimization is again supported on x86. So you will feel or you will find the optimization taking effect on x86 platform alone. So running through the details of running through further details of what this IPP is, this is actually supported on cross-platform, or this is supported across different Intel platforms used in different form factors. So as you can see in the right-hand side block, this is supported on phones, tablets, ultrabooks, as well as servers. So IPP is supported on Atom, Intel Core, as well as Xeon processors. If you have intense computing functionality within your application, you can always leverage on the optimization that is done in the IPP library and take advantage of it. So this just explains in plain text of whatever I have showed you on Eclipse. This, you can use this as a reference whenever you would want to include IPP in your application. So one small exercise that you could also do is you can build an IPP version of your application and a non-IPP version of your application, and you can go back and use the GPA kind of a tool to really analyze the performance difference. So right now I don't have a non-IPP version of the application that I showed you, but then if you have a non-IPP version, you can always do that comparison. And what we have seen from the sample apps that we have ourselves developed, and also with a few of the partners that have used our IPP, that there is significant performance improvement by using the IPP library. This is again a snapshot of what needs to be done in android.mk file that I anyway have showed you using Eclipse. This is about, so when you install Intel IPP onto your system, by default you get the Hello IPP simple example that I have shown you. This describes in detail on how you can go about importing it and using it as a reference for your application development.